x comma y is any point on the ellipse x square by a square plus y square by b square is equals to 1 when a greater than b, then whose foci are s and s dash, then show that sp plus s dash p is the constant. So given that p x comma y is any point on the ellipse x square by a square plus y square by b square is equals to 1. This is the diagram of the given ellipse. Condition is a greater than b here. So this is the diagram. Given that p x comma y is any point on the ellipse. Now this is the point on the ellipse, and also given that s comma s dash are the foci. So this is s and this is s dash. Now we want to show that sp plus s dash p is the constant. So these are the directrices, first equation, first line and second line. Now first we are taking that sp is the distance between the points and pm is the perpendicular distance from p to the directrix here. Z is the foot of the perpendicular from s to the directrix, and this is the point a here. This is a dash, and we take this point as z dash. Now here clearly from the definition of the ellipse we have that sp by pm is equals to e, and also from the point p we are drawing one perpendicular from p to the x-axis, and we are taking this point is equals to L. So clearly here we have that sp by pm is equals to e, that is the definition of the ellipse. And what is pm value? Pm is equals to Lz. Since these two lines are parallel, pm is equals to Lz, and in place of Lz we take the value Cz minus Cl. By using that value we can find the value of Sp. Similarly we find the value of S dash P. First we are joining the points S dash and P. This is the line, and we are drawing one perpendicular from P to the second directrix, and we take this point is equals to m dash. By applying the definition of the ellipse we get S dash P by Pm dash is equals to E, and the value of Pm dash is nothing but Lz, since these two lines are equal. So by using those conditions we can find the value of Sp and S dash P. Now this is the diagram. So first we are writing the given data. What is given? Let Px comma y be any point on the ellipse. First we are taking that point here. Let Px comma be any point on the ellipse x square by a square plus y square by b square is equals to 1 where a greater than b. Now by definition of ellipse we have that Sp by Pm is equals to E, which implies Sp is equals to E into Pm, and that is Sp is equals to E into Pm. What is Pm value? From the diagram we have that Pm is equals to Lz, that is Lz equals to, here this value is equal to Cz minus Cl. So in place of Lz we write the value Cz minus Cl, and this is equals to E into Cz. What is Cz value? Already we know that the distance between the directrix and y-axis is equals to a by a. So we are taking that value here, a by e minus Cl. Cl is nothing but the x coordinate of the point P, which is taken as x here. Now multiplying these two values by e we get the value a minus xe. Now this is the value of Sp. Since P is a point on the ellipse, we are applying the definition of the ellipse with respect to the second focus, that is S dash P by Pm dash is equals to E, which implies S dash P is equals to E into Pm dash, and this is equals to, what is Pm dash from the diagram? This is nothing but Lz dash. Lz dash, and this is equals to E into Lz dash. What is Lz dash value? Cl plus Cz dash. Cl plus Cz dash, and this is equals to A into Cl. What is Cl value? X coordinate of P, that is x plus Cz dash. Again the distance between these two lines is equals to A by E, which returns the value xe plus E. Now we want the value of Sp plus S dash P, that is therefore Sp plus S dash P is equals to, what is Sp value? A minus xe. A minus xe plus S dash P value xe plus A, and this is equals to 2A, which is constant. What is 2A? 2A is nothing but the length of the major axis, that is constant. Therefore Sp plus S dash P is constant. That's all. This is the answer. Equation of the ellipse with focus at 1 comma minus 1, E is equal to 2 by 3 and directrix as x plus y plus 2 is equal to 0. Find the equation of the ellipse. We have to find the equation of the ellipse here. Given that focus is equal to 1 comma minus 1. So that is S point. S is equal to 1 comma minus 1. E is equal to 2 by 3. So given that eccentricity is equals to 2 by 3 and directrix as x plus y plus 2 equal to 0. This is L equal to x plus y plus 2 equal to 0. Now we want to find the equation of the ellipse. When we have the focus and directrix, then we find the equation of the ellipse by applying the definition of the ellipse, that is SP by PM is equals to E. Already we solved these type of problem in parabola also. When we have the focus and directrix in the conic problem, then we solve the equation of the conic by applying the definition of the conic, that is SP by PM is equals to E. Here also we use the same concept. So first we write the given data. So given that focus is equals to 1 comma minus 1, that is focus means we take this point is equals to 1s. We take this point as s. S is equals to 1 comma minus 1. And also given that eccentricity is equals to 2 by 3, that is E is equal to 2 by 3. And equation of directrix is x plus y plus 2 is equals to 0. So to apply the definition, first we take that let p x comma y be any point on the ellipse. Now we apply the definition. Now by definition of ellipse we have that SP by PM is equals to E, which implies SP is equals to E into PM. Now we are replacing the values here. What is SP? SP is nothing but the distance between the points S and P, that is square root of x minus 1 whole square plus y minus minus 1, that is y plus 1 whole square is equals to E value. E is equals to 2 by 3. 2 by 3 into PM value. PM is nothing but the perpendicular distance from the point Px comma y to the directrix, that is under modulus x plus y plus 2 pi square root of x quotient square plus y quotient square, that is 1 square plus 1 square, 1 plus 1, which implies square root of x minus 1 whole square plus y plus 1 whole square is equals to 2 by 3 into this is x plus y plus 2 by root 2. Now this root 2 is cancelled by root 2 times here. By taking the cross product here, this is 3 into square root of x minus 1 whole square plus y plus 1 whole square is equals to root 2 into x plus y plus 2. Now squaring on both sides. Then we get 3 square, that is 9 into x minus 1 whole square plus y plus 1 whole square is equals to root 2 whole square, that is 2 into x plus y plus 2 whole square. Into we take the expansions here. Now this is x square plus 1 minus 2x plus y square plus 1 plus 2y is equals to 2 into taking the expansion of a plus b plus c whole square here, a square x square plus b square y square plus c square 4 plus 2ab 2xy plus 2bc 4y plus 2ac 4x, which implies this is 9 into x square plus y square minus 2x plus 2y plus 2 is equals to multiplying all those values by 2 there. So 2x square plus 2y square plus 8 plus 4xy plus 8y plus 8x. Multiplying all those values by 9 here. 9x square plus 9y square minus 18x plus 18y plus 18 minus 2x square minus 2y square minus 8 minus 4xy minus 8y minus 8x equal to 0, which implies, so the first value here 9x square minus 2x square 7x square, and the next value minus 4xy, next value 9y square minus 2y square plus 7y square minus 18x minus 8x minus 26x plus 18y minus 8y plus 10y, 18 minus 8 plus 10 equal to 0, which is the equation of the ellipse. Find the length of the major axis, minor axis, latus rectum, eccentricity, coordinates of center, foci and equations of directrices to the following ellipse. The first problem is 9x square plus 16y square is equal to 144. And the second problem 4x square plus y square minus 8x plus 2y plus 1 equal to 0. Now here two equations are given, two ellipse equations are given. Now we want to find all these values to each of the ellipse. So first we are writing the first equation. This is given equation is here 9x square plus 16y square is equals to 144. Now to find all those values, first we have to convert this equation in the known form of the ellipse. Means we are dividing this total equation by 144 here first. That is 9x square plus 16y square by 144 equals to 1. That is 9x square by 144 plus 16y square by 144 equals to 1. That is x square by 16 plus y square by 9 equals to 1, which is in the form of x square by a square plus y square by b square equals to 1. So we are comparing this equation with x square by a square plus y square by b square is equals to 1. Here the value of a square is equal to 16 and the value of b square is equals to 9. Therefore the value of a is equals to 4 and the value of b is equal to 3. And clearly here we get the condition a greater than b. A is equals to 4, b is equal to 3. Therefore a greater than b. X square by a square plus y square by b square is equals to 1. A greater than b means this is the first case. Equation of the ellipse in the standard form. Now we are using those formulas to find all this. That is, length of major axis is equal to formula 2a. So 2 into 4 is equals to 8. And length of the minor axis, the formula is 2b, where b is equal to 3. 2 into 3 is equal to 6. And length of lateral rectum, the formula is 2b square by a. That is 2 into, here we have that b square is equal to 9 by a is equal to 4, which is 9 by 2. And center is equals to this form, center is equal to 0, 0. And eccentricity E is equals to formula square root of a square minus b square by a square. That is a square 16 minus 9 by 16 equals to root 7 by 16, that is root 7 by 4. This is eccentricity value. And foci is equals to the formula plus or minus a comma 0, that is plus or minus a value 4 and e value root 7 by 4 comma 0. Now this is equals to plus or minus root 7 comma 0. And equations of directrices. The formula is x is equals to plus or minus a by e. That is, answer is x is equals to plus or minus 4 by root 7 by 4. That is, x is equals to plus or minus 16 by root 7. These are the equations of directrices. That's all. Problem 4x square plus y square minus 8x plus 2y plus 1 equal to 0. So first we write the given equation here, and in the next step we change the equation in the form of, first we write the terms x terms, that is 4x square minus 8x. Next we are writing the y terms, which are y square plus 2y equals to minus 1. That is, first in the first step we are writing the constant to that side. That is, here we have the plus 1 as the constant, writing that constant to that side, that is minus 1. It becomes minus 1. And taking x terms first, and next we are writing the y terms, which implies, now we are taking 4 common here for the first and second terms, that is 4 into x square minus 2x, plus here writing the next two terms like that, 4 square plus 2y equals to minus 1, which implies 4 into x square minus 2x plus 1 minus 1, that is adding plus 1 to this term to make it as a perfect square, plus this is y square plus 2y plus 1 minus 1. Here also we take the number plus 1 minus 1 to make it as a perfect square, which implies, now this is 4 into x square minus 2x plus 1, which becomes x minus 1 whole square. 4 into minus 1, that is minus 4, plus y square plus 2y plus 1, that is y plus 1 whole square minus 1 equals to minus 1. Here minus 1 and minus 1 gets cancelled. Now this is 4 into x minus 1 whole square plus y plus 1 whole square is equals to plus 4. Writing this minus 4 to that side, that becomes plus 4. Now dividing this total equation by 4, that is 4 into x minus 1 whole square plus y plus 1 whole square by 4 equals to 1, which implies separating the denominator, 4 into x minus 1 whole square by 4 plus y plus 1 whole square by 4 equals to 1. That is, x minus 1 whole square by 1 plus y minus 1 whole square by 4 equals to 1, which is in the form of x minus h whole square by a square plus y minus k whole square by b square is equals to 1. This equation with x minus h whole square by a square plus y minus k whole square by b square equals to 1. Then we get the values, h is equals to 1, this value, and k is equals to minus 1, and a square is equals to 1, b square is equals to 4. A square is equals to 1 means the value of a is equals to 1 and here the value of b is equals to 2. So clearly here we get that a less than b. A less than b means we take the second case formula. Length of the major axis is equals to 2b, that is 2 into 2 equals to 4, and length of the minor axis is equals to 2a, that is 2 into 1 equals to 2. Next, length of lattice rectum. Length of lattice rectum is equals to, this is second case, so we take the formula 2a square by b. In the first case we write the formula 2b square by a, but here we take the 2a square by b. In the first case length of the major axis is 2a and minor axis is equal to 2b, but here the a less than b case length of the major axis is 2b and minor axis is equals to 2a. Length of the lattice rectum, second case formula 2a square by b, that is 2 into a square value 1 by b value 2, that is 2 by 2 equals to 1. And center is equals, this equation we take the center is equal to h comma k, and here we have the values h comma k as 1 comma minus 1, that is center is equals to 1 comma minus 1. And eccentricity is equal to second case means we take the formula square root of b square minus a square by b square. In the first case we write the value square root of a square minus b square by a square, but this is second case we take the formula square root of b square minus a square by b square, that is 4 minus 1 by 4 equals to root 3 by 4, and this is equals to root 3 by 2. Now 4k is equals to the formula second case means we take 0 plus or minus be, but here we have h comma k also, so we write the formula as h comma k plus or minus be, and this is equals to h value 1 comma minus 1 plus or minus be, b value 2 into e value root 3 by 2. Therefore the points are 1 comma minus 1 plus or minus root 3. Now these are 4 key points. Now equations of directrices. The formula is second case y is equal to plus or minus b by e, but here center also. Therefore we take the formula y is equals to k plus or minus b by e. Now replacing the values, y is equals to k value minus 1 plus or minus b value 2 by e value root 3 by 2. That is, the answer is y is equals to minus 1 plus or minus 4 by root 3. 2 2s are 4 by root 3. That's all.